Hello everyone, I'm Tiantian Liu from Zhejiang University. I'm going to introduce our work, MicGuard, a compressed detection system against out-of-band injection text for different level microphone-based devices. Yes, it is a defense's work. Microphones capture sound allowing intelligent machines to understand human speech besides the phone calls and music recording. Compact MEMS microphones are widely used in smart homes, industrial applications, and new broadcast. They are essential in voice assistant, industry for detection, and broadcasting for communication and entertainment. The high-level and low-level microphones provide our convenient type of entertainment. However, microphones face many attacks as before the talk, like laser tag. Looking through this out-of-band case, on microphones, we can see direct tag, ultrasound tag, famous dolphin tag, and laser tag, famous work like comments, and electromagnetic tag. These tags rely on the signal out of the normal frequency range and all the interval transmission passes to inject malicious signals into microphones for disadvantage or sabotage. They are also called out-of-band injection tags. The tag modulates the malicious audio on the out of a crystal wheel. The crystal wheel, including ultrasound, laser, electro wheel, and transmit into the microphones. For instance, they can emit electro wheel interference to manipulate signal recording for the compressing the liquid communication system, or emit lasers into the sensor fusion system. Like the first work before talk, ASR systems. However, operator work against the injection tags on microphones are limited to mitigating embedding injection tags, and all further including ultra tags. Yes, they always limit the embedded attacks of further ultrasound tags. Compared with the existing detection scheme, the design detection phasing out-of-band signals need to meet the following requirements. First, no extra hardware modification, like speaker and microphone rails. Because the hardware modification detection methods will bring additional burden for users, especially for low-level microphone devices. These sensors cannot support the hardware modification. Second, independent of the adverse samples. 3, low dataset cost. And last, high accuracy and robustness. These requirements make it easy to deploy the detection defenses on all microphones from high level to low levels. To satisfy the requirements of the usable and efficiency, we need to know that out-of-injection tags deeply is a prelude to defenses mechanism desire. We execute the 3 out-of-band injection tags on commonly used microphones. We select the sum results of spectral in these slides. Looking deeply at the spectrum of injected audio, we find that frequency traces, like the straight line spanned in the time domain. Regarding this phenomenon, we find that the observed frequency traces are the result of the frequency shift of the single frequency signal during the ADC sampling. The frequency value is exactly equal to the clear frequency. Well, the reason for this phenomenon calls the lasers as follows. In laser tags, yes, a TTL-based laser tags, not M2. Because the laser tag choose a laser being driven by TTL, the modulation where the carrier signal is a PW of optical signal. The clear signal will vibrate the microphone diaphragm consistent with its frequency, so that the victim can record the clear. Yes, TTL-based the laser tag will has the phenomenon, not amplitude modulation. Lasers tag. TTL's laser tag is more cheaper. Okay. But in ultrasound tags, these traces, the query is the queer wheel of the ultrasound is always I see filtered out by the microphone's low pass filter in many people. We also said, but actually practice the filters effectiveness dropped gradually rather than complete cutting off. So it means that a strong queer wheel will still passing the low pass filter, especially in high end of them. Especially in high-level microphones with less strict filtering. Yeah. While in electromagnetic attacks, they also need queer, but the queer is used to electrostatic couple. So it's neither actual sound or neither sound resources inside the microphones. Thus, the electromagnetic attacks cannot bring about the queer traces. Considering the potential co-occurrence characteristics in the results of the ultrasound-induced and laser-induced attacks, we can leverage the characteristic of the queer trace to quickly determine whether an out-of-band attack exists. Next trait is the disorder in audio. On the one hand, out-of-band signal can cause a new parasitic resistance or capacitances, which can lead to duration in the sample audio data. On the other hand, due to the fact that the internal components of the microphones are specifically designed for in-band signals rather than out-of-band signal, so the out-of-band signal can produce many byproducts, including multiple harmonics or even crosstalks, which can cause distortion of the audio signal. To prove it, we used to use the Zhan entropy to quantitatively assess the chaos of the audio samples recorded from diverse victims exposed to various out-of-band injection attacks. We found that the injected audio exhibited higher entropy compared to the original audio, indicating that the injected audio has intense chaos. These findings motivates us that decide of a detection method that uses the chaotic entropy from the out-of-band signals injection in different devices as the key trait to identify and detecting audio. Based on findings, we decided MicGuard, a defense system that first filter out to partially inject out-of-band signals and then identify the anomaly using entropy extraction and a memory-based detection model. Notably, creatures in spectrum exhibit a horizontal line across the whole time domain. Based on it, we only need to detect the extent horizontal line in audio spectrum received by microphones to determine whether an abnormal signal exists. Well, the idea is very forward. We propose a prejudged algorithm to identify that the zero real scope spectrum exists. Our approach is more accurate than the traditional method is vision light detection. This detection method is more complex, is not adapting our defense, which also squared with detecting this light in noisy spectrum. This section focused on extracting chaotic features as from the capture sound as discussed before. We used the chaotic as a criterion for the detection. We use the spectrum chaotic entropy extraction to comprehensively extract this chaos. We test different entropy measures, such as power spectral entropy, sample entropy, and local entropy, using Tiantian to visualize the distinction between the original and out-of-band audio. The result shows that the power entropy provides the most distinct, so it's chosen as our matrix. This section aims to identify anomalies from out-of-band signal using the spectrum chaotic maps. These things, the anomalies are unpredictable during the training and collecting. And collecting normal data is also very cost. So we decided MicGuard memory-based detection method. This method, the training dataset is from the open source dataset. So the training dataset cost is very low. The subsystem consists of 3 modules. feature encoding, feature adaptation, anomaly inference. In feature encoding, we used a pre-trained model to encode the spectral chaotic maps to build a memory bank from the normal audio samples. Imagine a memory bank consists of our normal features. In feature adaptation, we fine-tune these feature maps using deep spot vector data description to form the higher hypersphere around the normal data for normal detection in anomaly inference. One input test feature. The memory bank using multivariate Gaussian model and calculate distance, the input features and the stored features, calculate the distance and decide whether it is an anomaly. Yeah. Then in evaluation, we evaluate MicGuard on various microphones. Ambient successful injection tests can employ sophisticated hardware and powerful energy resources to execute Hangzhou laser attack in electromagnetic wave attacks. Notably, in the training phase, we choose the open source library corpus of English speech to fully pre-train the MicGuard to build our memory-based detection model. Yeah. And I think this is overall performance. MicGuard achieves strong defense performance across the various devices. This system can counter out-of-band audio attacks while accurately processing general audio sampling across various devices, from high level to low level, as we discussed before, and regardless of this attacking power. Yes. Also, in robust analysis, MicGuard shows a significant defensive performance under the impact of noise injected contact. We also investigate the amount of the training set, increase the amount of the training data, improve the accuracy and recall in deep learning, but beyond 17% the gains are modest, indicating that simply adding the more data may not significantly enhance the model generation. In this case, we investigate the attacking precision of the effective MicGuard. Our system effect block malicious signals from different angles and distance with a very, very low FPRs. As the distance increase, this signal energy dissipate, revealing out-of-band characteristic and orientation changes have a minimal impact on our system performance. Yeah. In comparison, compared with other out-of-band defenses, our system have the following advantages. First, hardware independent, suitable for a range of the devices from the low-end sensors to smart home devices, and is no protected data required. Yes, this makes it more adaptable and critical since gathering malicious data is labor-intensive and is unpractical. And this is a comprehensive defensive scope, since the previous work always focused on the in-band attacks. In our work, we try to defend against the 3 types of out-of-band injection attacks. Yeah. Conclusion, this study tried our best to fill the bank of defenses against out-of-band injection attacks. MicGuard does not rely on predate and from text or text and using creatrix as a print criterion and incorporating quantified chaos from the open source dataset into the memory-based model for detection, and comprehensive evaluation on various devices shows our system's performance. Yes. Last. I would like to take a moment for my personal note. I'm completing my PhD next year, and I'm currently seeking for a postdoctoral opportunity for 2025 job market. Yes, I'm comfortable in my ability, and I believe I can make a significant contribution to researching. If you are willing to give me an opportunity, I will be grateful. Yes.